In this video, I will talk about measures of position. The objectives would be how to find the first, second, and third quartiles of a data set, how to find the interquartile range of a data set, and how to represent a data set graphically using a box and whisker plot. Quartiles approximately divide an ordered data set into four parts. You have the first quartile, denoted as Q1, and that's about 1/4 of the data will fall on or below Q1. The second quartile, which is your median, and this is about 1/2 of the data set, will fall on or below Q2. The third quartile, Q3, is where about 3/4 of the data fall on or below Q3. Excuse me. So let's look at an example. Each year in the U.S., automobile commuters waste fuel due to traffic congestion. The amounts in gallons per year of fuel wasted by commuters in the 15 largest U.S. urban areas are listed. We're going to find the first, second, and third quartiles of the data set, and we're going to see what we observe. So this is the data set. It goes from 20 all the way to 35. And you have to put it in order. Excuse me. So we're going to go ahead and put the data in order, and we're going to find the overall median of that data set. So as you can see, 25 is the median of the data set. That splits the data into two halves. So now we're going to look at all the values that fall below 25. So it goes from 11 to 25. As you can see, I have marked it in red. We're going to find the median of that data set. The median of that data set is your Q1. So looking at that first half, the Q1 is 23. That's your first quartile. Then we're going to look at all the data values that come after 25, that come after the median, the overall median. And we're going to find the median of that data set. That will be your Q3. And in this case, it is 30. So what does this tell us? In about 1/4 of the large urban areas, auto commuters waste 23 gallons of fuel or less. So if you go back, 23 was our Q1. About 1/2 waste 25 gallons or less. As you go back, that's our median, our overall median, which is Q2. And about 1/2 waste 25 gallons or less. Excuse me. And about 3/4 waste about 30 gallons or less. So that would be our Q3. From this information, we can calculate the interquartile range, which is called the IQR. It's a measure of variation that gives the range of the middle portion, or about half of the data. So in order to calculate the IQR, you take the difference between the third and first quartile. So you take Q3 minus Q1. So in this example, Q1 was 23 and Q3 was 30. So if you subtract those, you get 7. So all of this information can be obtained in StatCrunch. So let's go ahead and go to StatCrunch. And I already have my data listed. I'm going to go to Stat, Summary Stat, Columns, and I want to pick gallons. And then the information that I want is Q1 and Q3. Oops, so here's Q1, here's Q3. And then I also want IQR, so I'm going to hit the control button and hit IQR. And all of this will pop up over here in the right box. I hit compute, and I get 23, 30, and 7. And that's what we got before. Q1 is 23, Q3 is 30, the IQR is 7. Recall I said Q2 is the median. So if you wanted to calculate the median, you just pick the word median. And that would be right here, median. So if I do it again, I want median, I want Q1, I want Q3, and I want IQR. So hit compute. And there you go. So you have your Q2, which is the median. We can use the IQR to identify outliers. So in order to do this, first you have to find Q1 and Q3, and then you calculate your IQR. You're going to multiply the IQR by 1.5. So it's 1.5 times the IQR. Any data entry less than Q1 minus 1.5 times IQR is an outlier. Any data entry greater than Q3 plus 1.5 times the IQR is an outlier. So let's go back to our example. We're going to see if there are any outliers in the data set. So we already calculated the IQR to be 7. I'm going to take 1.5 and multiply that by 7 and I get 10.5. I'm going to take the 10.5 and I'm going to subtract it from Q1. That gives me 12.5. I'm also going to take the 10.5 and add it to Q3. That gives me 40.5. So any data entry less than 12.5 is an outlier. Any data entry greater than 40.5 is an outlier. So I put our data set back up here, and as you can see, 11 is less than 12.5, so 11 is considered an outlier. So in large urban areas, the amount of fuel wasted by auto commuters in the middle of the data set varies by at most 10.5 gallons. Notice that the outlier 11 does not affect the IQR. The next thing we're going to do is use this information to draw a box and whisker plot. So this gives you a visual and it highlights important features of a data set. And it requires a 5-number summary. The 5-number summary is your minimum data value as well as your maximum data value. And then of course your quartiles. You need Q1, the median, Q2, and Q3. We'll use that information to draw a box plot. So in order to draw the box plot, you're going to use Q1 and Q3 to form the box. So if you look at the picture, I have Q1 here, Q3 here. And then we'll draw a box, and the median will be a line somewhere in the middle of the box. It could be directly in the middle, it can be closer to the edges. It depends on your scale. Next, we're going to draw whiskers. The whiskers will go out to your maximum value and your minimum value. So if we go back to our example, our minimum value was 11, our maximum value is 35. We got the quartiles and our median. So when you draw this box, as you can see, Q1 and Q3 form the box. The median is inside the box, it's 25. And then the whiskers go out to the smallest value, which is 11, and the maximum value, which is 35. The box itself represents about half the data, which are between 23 and 30. The left whisker represents about 1/4 of the data, so about 25% of the data entries are less than 23. The right whisker represents about 1/4 of the data, so about 25% of the data entries are greater than 30. Also, the length of the left whisker is much longer than the right one. So this indicates that the data set has a possible outlier to the left. And we already said that 11 is considered an outlier, so that's an outlier to the left. So we can use StatCrunch to draw a box plot. So if we go to Stat and we go to Graph, we go to Box Plot, and we want to graph the data that's in the column gallons. And you can draw it so it can show you the outliers, or you can draw it without the outliers. So I'm going to unclick this box where it says use fences to identify outliers. And I'm going to draw my box horizontally, so just like the one you saw on the slide. I hit compute, and this is the graph of this is the box plot of the data. So if you take your mouse and put it over some parts of the box plot, it'll give you information. So it tells you your IQR, your minimum, your maximum, the median, and the quartiles, 23 and 30. Uh, and as you can see, this left tail is longer. If we draw it so it indicates what the outliers are, go back to box plot, gallons, and this box here that says use fences to identify outliers. When I hit compute, this is the graph. And as you can see, if we put our mouse over here on this little dot, this is an outlier, and it's 11. And that's what we said before, the 11 was an outlier. So you will want to draw it. If you want to see what the outliers are, you have to click on that box. If not, it won't show you the outliers. And the reason why I don't have anything for Excel is because Excel calculates quartiles differently than StatCrunch, and your homework is based off StatCrunch numbers. So their algorithm for calculating quartiles. So I don't show you how to do quartiles in Excel because they're going to come out a little bit different. They may come out the same, but you can mess around and see. Well, let me see. No, I don't have my Excel open. I will show you, but don't try to use. I mean, they actually have commands in Excel for quartiles, but like I said, you may not get the same answers as you would if you did it in StatCrunch. That's the end of this lecture.